Hey class, in this video we're going to be adding some physics to our player controller script. So we'll be working with the player controller script from the previous lab, the programming intro, and we're going to be adding some gravity and jumping to that script. So that script would be fine for like an RPG style game where you can walk around in any direction. This script will be more for a platformer style game where you fall and can jump between platforms. We'll continue working with the Godot project. We also have a developer default project that you could start with if you don't have the previous project for some reason. You can also download the assets if you need to add stuff in there. The developer default folder has a couple things in there that you'll need, like a menu for some UI that we're going to use in the example. So it may be easier just to start there as well. But if you have a project that you've been working on, feel free to start with that and just add the files in there. The first thing we're going to do is just add some physics scripting to our player controller. Once we've got that working, we're also going to add a quick scene manager script, and we'll go over how that works. In the previous lab, in the programming intro, we introduced a lot of new programming concepts. In this lab, we're going to use some of those concepts again. So hopefully we'll be able to strengthen our understanding of those concepts. We're also going to be introducing a couple new things that are specific to Godot that we'll be using in our game development. We'll also do some documentation as usual, just adding screenshots or video to the open lab. And there's a bonus for this lab. If you can figure out how to add a double jump, I'll give you a bonus point for that. It's not in the code, so you'll have to work on it on your own using the concepts that we cover. You can find the full scripts for the player controller and the scene manager in here as a reference. That's what we will be writing in this lab. So let's get started. So to start, we are going to download the developer default folder. There's a few different ways you could set this up. So if you already have a game that you're working on, feel free to start with that. Or you could start with the programming intro, but there's a few new files in the default developer folder. So the easiest way might be just to copy the scripts that you created last time and throw those into the developer default. You can see there's a menu script in there that does a couple of things for us. So there's a few different ways you could set it up. If you have issues with this, let me know and we could talk about the best way to do it. But the easiest way is probably using this default project. Once you've got Godot open, go ahead and open up the default scene. You can see we have a player that's already set up with the camera, and there's a little tile map in there so that we have something to land on when we add some physics. And so those are some things that you might not have in your original project that you might want to include in here. So you could grab those assets from the assets folder or just the default developer project. So let's add our player controller script to the player. And so you can see with the kind of basic character controller script that we made, we can move in all four directions. And you can see the collisions actually work in this case, even though we haven't added our own physics yet. But what we want to do is add some gravity and jumping so that the platforms will act more like platforms. So let's save this script. I'm just going to duplicate it and call it player simple. So we could use that later. That could be useful for like an RPG style game, something like that. But we'll keep editing the player controller script when we add in our physics. So that way it's already attached to the player. So that's a simple setup. So here's our player controller script from where we left off in the intro programming lab. And what we're basically going to be doing in this lab is adding some really basic physics to the player to set up our 2D platformer. So with the 2D platformer, we want to add some gravity. The player is going to be falling towards the ground and then landing on platforms. And the player will also be able to jump, but we'll add that next. So let's go ahead and add some gravity. I'm going to use the export variable. So remember, the export is going to add in that property that we can edit in the editor. 800 is what they used in the Godot documentation, so that's why I used it. And you can see that doesn't actually change anything. We've just created a variable that saves the amount of gravity that we want to apply, but we have to add some other code to actually apply the gravity to the position of the player. So we've got that set up. Let's go to our player update function where most of our code is going to go. So even though we're just creating imitations of physics in code, we do want to model our imitations on how physics work in the real world so that they will seem realistic to the player. So when it comes to gravity, what scientists have observed is gravitational acceleration. And acceleration is the increase in velocity over time. So the way that gravity works is that your speed as you're falling towards the ground gets bigger and bigger. It doesn't stay at a constant rate. And so for that reason, we need to get rid of velocity.y equals 0 because we can't reset the player's velocity each frame if we want to recreate that force of gravity. After that, we can remove the inputs for move up and move down because the player can no longer move the character freely up and down. Instead, we're going to apply the gravity and we'll apply a jump force against that gravity. So after we apply the move and slide to the velocity using the right and left movement, we're then going to apply the gravity. So we can say velocity.y plus equals gravity times delta. And now you see that our player falls. And so we've successfully added gravity to the player just with a few lines of code. So one thing I want to point out here is that delta, we saw that in the last lesson, but we didn't actually use it for anything. Delta is a value that Godot calculates, and it's the amount of time that passes between each frame that's rendered on the screen. And this is a very, very tiny amount of time. It's like 16 milliseconds or something like that. It should be about 1/60th of a second because Godot is going to be running about 60 frames per second. And the reason that we apply this to the gravity is so that it's relative to the time or the speed that the engine is running. So if there is like a slowdown for some frame, or if one frame takes longer to render than another, we won't see like a big jump in the time of the physics. And you might be wondering, why didn't we apply that to the speed earlier? And part of why is because that's actually one thing that the move and slide function does, is it calculates that delta for us. So it's a built-in Godot function that is also using that delta time. So when we're using gravity, since we're adding that ourselves, we do have to incorporate the delta value there. And then as far as adding gravity, we're basically done. So Godot does a lot of the work for us. And so we can just add a few values and Godot will kind of apply that velocity for us. And so we've got some gravity. The one other thing that I want to add in here is a little check to see if the player falls below a certain height. And then we can, end the scene or do a game over or reset the player. So that way the player can't just fall infinitely, which can be a problem if we don't have enough platforms to catch the player. They might just fall forever. There's different ways that you can set this up. The easiest way to do it, just using code without adding anything else into the scene, is just by calculating the size of the window. And then we can kind of assume that if the player falls below 2 heights of the window, then they're probably outside of the screen. And so we can do a game over or reset the game. So to do that, I'm going to write a little if statement. I'm going to say if, and we're going to first check, make sure the player is still alive. So we're not calculating this against a dead player. So we say if is alive. And what we're going to check is the position.y. Remember that y gets greater as we go farther down the screen. So if position.y is greater than the viewport, which I can get just by using a little Godot function called getViewport, and then .size.y, that tells me the height of my game window. And let's multiply that by 2. And if our position is greater than that value, that means our player is like very far below our game window. So we can set them to be no longer alive. We can say is alive is false. And then we're also going to write a new little function here that we are going to extend a little bit later to say when the player dies, what's going to happen. And for now, we're just going to play the animation that shows the player dying. So let's make sure that works. I'm just going to fall. And yes, we see that at a certain point, we stop falling and the player dies. And so we're going to add a little bit more in here later to connect it with another script. But for now, that's pretty much everything we need to do as far as adding gravity. So the next thing to do, since it is a platformer, is to add a jump force. And the jump force is basically something that we can apply that works against gravity. So when we tell the player to jump, we'll apply a force in the opposite direction of gravity, which will make the player go up. And then gravity will bring the player back down. We are going to create another export variable for the jump force so that that's editable in the editor. And I'm just going to try a value that's half the value of gravity. Let's just see if that works. And we can always adjust that later. So we're going to add in a new input. And this function is a little bit different than the one that we used for the right and left. This is an input called isActionJustPressed. And so basically what that says is, did we just hit the key? Not, are we still holding the key? So once we hit jump, we don't want to keep jumping forever. We just want it to happen once, unlike our right and left keys, which can continue happening after we started pressing them. So we say, is action just pressed? And then we use jump, which should be mapped to the X key or the spacebar key. We went over the mapping in the previous lab. If you don't have that in your project, let me know and we can set that up real quick, or just go back and look at lab 1 in the developer tier. So we can add an if statement here. So if the player hits the jump button, we are going to apply this force, and we're going to apply it in a negative direction on the y velocity. And we're just applying it once, so we don't need to multiply it by delta, because we're basically just adding this really big upward force. Gravity kind of controls the rest. So because we're always applying gravity, the jump does start to slow down as the player gets up, and eventually the jump is going to even out and then fall back towards the ground or the platform. And so that looks pretty good. We can test that in the game, and you can see it does work. There's one little problem, which is that I can jump as many times as I want. And so we're going to have to add in a check for that. So another condition that we can add to make sure that our player can't jump more than once is to check, is the player on the floor? Godot has that built in because it's very common in games. So we can ask, not only did we press the jump button, but are we on the floor? So we can say, so input is action just press jump and is on floor. Then we add the jump force, and that prevents us from jumping a million times. So we have to wait until we hit the floor again before we'll be able to jump again. So that works pretty good. One thing that we might want to enable for the player is a wall jump. So you don't have to do this part, but I like having the wall jump in there. It gives me a little bit more options for how the player might play. And we can also make a little Boolean export value so that we can set this in the editor. So we'll just go up and add another value, wall jump enabled, and we can default that to false. So you have to turn it on for it to work. And then we kind of have to adjust what the if statement is, the question that we're asking before we jump. So we can, to simplify this, we could write it as one big gross line, but to simplify it and make it a little easier to read, let's add another line. And so we'll create another variable called can jump. And so this just says whether or not we're able to jump. And this is going to basically test whether we're on a floor or a wall. So we can say if we're on a wall, or, and here's a new concept with Booleans, we can put two statements inside of a little parentheses to test them together and then add that back to the statement that we already started. So this one's a little bit more complicated. If you leave this out, that's totally fine. But basically we're going to say if we're on the floor or wall jump is enabled and we're on a wall. So that'll check to make sure that we are either on the floor or we're on the wall and wall jump is enabled. So this is kind of a complex line of code. So let's go over the possibilities. So we start with the variable can jump, and it's either going to be true or false. So remember, a Boolean can only be true or false. But there's three different things that we're looking at. The first is just if it's on the floor, and if it is, that's an or statement. So as long as one of the sides of the or is true, the whole statement will be true. So if it's on the floor, it'll be true regardless of what happens after the or. If the is on floor is false, that's when we are going to look at the other statement that's on the other side of the or, where we look at both wall jump enabled and is on wall, and both of those have to be true for that to be true. So if both of those are true, then even if the is on floor is false, we still get true. So let's actually map that out. So if is on floor is false, then both the other side has to be true. So if wall jumping is not enabled, but we are on a wall, then we can't jump. If is on floor is false, wall jump is enabled, but we're not on a wall, then we can't jump. If is on floor is false, but both wall enabled and we are on a wall, if both of those are true, then it's true. And if is on floor is true and either wall jump enabled or is on wall or both are false, then it's still true. So then we can replace that is on floor with our new can jump value. And that just says whether or not we can jump. And if we can, and we click jump, then we are going to apply that jump force. So now we're going to update our animation real quick. We want to show that jump animation if we are jumping. And this is actually pretty simple. We're just going to say if we're not on the floor, then we are jumping. So we're just going to check if not is on floor. So that means we're not touching the floor. Obviously, I could add the is on wall there as well, but we probably aren't jumping if we're stuck to the wall. So we can just leave that as is on floor for now. And if we are not on the floor, then we want to play the jump. And that's pretty much, we can just start with that statement because no matter what else is happening, if we're going right or left or any direction, if we're not on the floor, we're going to be jumping and we only have one jump animation. So that's our first thing that we check in our animation if statement series. You can kind of play around with that if you do want to add other types of jumps and other stuff in there. That might be a good place to kind of play with some different options. If you have multiple animations for different types of jumps, like maybe a beginning jump and an ending jump. But we're just going to kind of keep things simple. I have this jump animation where we have a few frames at the beginning and then it doesn't loop. So as long as we're falling, we see that same frame. So it's a very simple setup with the mostly sort of built-in Godot stuff that is making it work. The next thing we need to do is adjust our walk animation. And so here we actually have to introduce a new programming concept, which is else if, or in Godot script, it's written elif, E-L-I-F. And what that essentially means is if the first condition is false, then we'll go to the next condition, but we're actually going to evaluate something else before we go to that else, which catches everything else. And this is something that we need to do because there are three different options. So our Booleans are usually true or false. So something either is true or not, and we do one thing or another based on that option. But if there's three options, then we need to evaluate another condition. First, we're going to check if we're not on the floor. If that's not true, meaning we are on the floor, then we want to check if we're moving. And we have to update that code as well. But after we check if we're moving, if we are moving, we play the walk animation. If we're not moving, then we go to that last statement, the final else, which will play the idle animation. And so that will happen if we're on the floor and we're not moving, and basically any other condition that isn't caught by those first two conditions. So instead of looking at either up and down movement or right and left movement, we only want to look at right and left movement. And so there's an easy way to check for that. We want to look at the x value of the velocity. One thing that we want to make sure is if the value is negative or positive, we're still going to play that walk animation. So we can use absolute value to do that. Absolute value is just a math function that takes the value and then gives you the absolute distance from zero. So 1 and -1 are the same distance. They're both 1 away from 0. So that's what the absolute value is it basically says either 1 or -1 is the same value. So we can ask if the velocity.x is greater than 1, that means we're moving. We might be moving right, we might be moving left, but either way, we're going to play the walk. And then we have some code later that determines which direction and then flips the sprite. So we don't have to do that at the same time. So that's all we really have to do to update our animations. It's pretty simple. The way we set it up, keeps everything very simple. There are more complicated things that you can do if you want to add other animations. If that's something that you want to do for more specific animations, we could talk about how to approach that. One last little detail that we do have to add in is that sometimes if you start a jump, but then you hit the floor or something else happens, you could maybe not make it all the way to the end of the jump animation. So just to make sure that doesn't happen, this is something you may never notice, but let's just set the frame back to 0 when we start our jump. That way we can be sure that a jump animation always starts at the beginning. So that's just a little quick fix for that. And then we have one more thing that we have to do that is related to sound. So you may not have done any of the sound labs yet, but one of the things that we do want to eventually do with our games is add sound to them. So we can start simple and add a sound for when the player jumps. So the first thing we need to do is know when to play the jump sound. And that's really easy here because we already have the code that makes the player jump. And so we can just play the sound along with that code. So when the player presses the jump button and we detect if they can jump and add that jump force, we'll just play the sound at the same time. And so let's add a little comment there and then go take a look inside the player scene. If we actually open up the player scene, you'll see the sound files if you're using the player from the default lab project. If you don't see sound files there and you haven't done the sound lab yet, you can skip this part. It's okay if you don't have this at this point. But if you do have the sound files and you want to play them, it's pretty easy to do. We're going to use the $ again to reference that jump sound that you see in the player scene. And we just say jump sound.play. And so it looks pretty similar to the animated sprite. Again, the $ is just referencing something that's inside of that scene. And so that's an easy way in the code to reference components in the scene. And then once we reference that jump sound, we can use the function that's part of jump sound to play the sound. And so it's just like the animated sprite, but we don't actually have to give it a name because the jump sound is just one sound, so it's always going to play the same thing. Playing a sound for when the player hits the ground or hits a wall is a little bit more complicated. We have to add in some new code to make that work. And so we actually have to know if the player is jumping so that basically we can play a sound when they stop jumping. So let's go back up to our variables and add in something new. This is just one of our private variables that's part of the script. We're just going to create a new variable isJumping, and we'll start that as false. And we might want to actually change that because sometimes our player starts in the middle of the air. So we can do that in the ready function. So let's add in a quick ready function. We talked about that, what that does in the previous lab. It basically just runs some code at the beginning of the scene once, and then that's all it does. And so we can just check if the player is not on the floor, then we do want to say that they are jumping so that we hear that sound play when they hit the floor. So then once we've done that, we can go back into our player update code. And after we apply the gravity to the player, basically what we want to do is say, if the player is jumping and they are on a wall or a floor, that means that they were jumping and they've landed. And so we've detected the player has landed. And so first we just want to say is jumping is false because we know that they've landed on the ground. And then we want to play that land sound so we hear them hit the ground. And that's something that you might not have in your game yet. If you're using the default scene, you should hear that on here. I didn't record the audio for this video, so you won't hear it in the video. But if you're using the default scene or you've added sound from, I think, the first sound lab in the sound design area, then you should hear a sound there. If you don't hear a sound and you think that you should, let me know, we can go over it. So that's pretty much everything that you have to do for that. Then we just have to go back into our jump input area and just make sure that we do set that is jumping value to true when the player jumps, because otherwise we won't know that the player is jumping. So that's the last little bit that we have to do. And there's one more sound effect that gets played by this script. So let's go ahead and add that in. When the player dies, we just want the dies sound to play. So that's another one. You might have it if you've done that lab or if you're using the default. If not, don't worry about it. We can add it later. And so that's it. We've got everything set up for our player controller. We've got gravity, we've got jumping, we've got some new sounds, we've got some new animations. This is a very simple setup that hopefully will make sense for our games. There's a lot of ways that we can extend this. If we get through the first bunch of labs, maybe we can spend some time adding other stuff to this that you guys might come up with. So the last thing that we can do here is connect our script to our scene manager. So I go into this in a lot more detail in the previous scene manager lab, but we can add that in real quick and just review. So we need to start by adding a signal. And we can just say signal player hit. And we already have that signal set up. We can kind of have it do two different things. So we can use it for when the player goes beneath the canvas here. And so I'll just say emit signal and then player hit. And I'm actually going to give this an argument, and we'll update our function a little bit to use this argument so that it will just have the player die. We don't need to do that right now. We can do that later in our obstacle lab. So I'm just going to set it up like that, and the scene manager can just ignore that. So just to test that, we'll add in the UI. You might already have this set up. I'm just going to go through adding that in again real quick. So we can go to our default scene and get a canvas layer. And this is like a new canvas to render some graphics that are not part of our main canvas with our game stuff on it. So I'll add that canvas layer and rename it UI. And then I'm going to right click and link a child scene. and I'm going to choose the pre-built game over scene and throw that in there. And I'll just turn the visibility off. And so we just want to connect our signal from the player to the scene manager. And so that will trigger the game over UI to show up once we fall below that area that we described in our player controller code. So of course, to connect the signal, I'm going to go to the node section for the player and double click on player hit and then choose the scene manager. And remember to rename the receiver method to match that on player hit function. And so that looks right. And that should work. So let's give that a quick test. And that looks pretty good. So that's pretty much everything that we need to do here. There's other things that you might want to add to this, but we can discuss what you might want to do for your specific game in the future. For now, let's do some documentation and post on the Open Lab. So now we've got a game that there's actually like some stuff going on. So documentation is a little bit trickier. You might want to just record a video and post that. That's totally fine. I'm going to do screenshots again, just to kind of go over that. So I'm going to take some screenshots of like the UI, a couple other things happening. One thing that I might want to do to get a screenshot of something in action is by using Command-Shift-3 to take a screenshot of the whole screen so that I don't have to set up the screenshot and then click, so I can be playing the game and taking the screenshots at the same time. And if I do that, I can just edit the screenshot. So let's just do that real quick. I'm going to go into Preview on Mac, and I'll just use the selection to select the area I want to crop, and then just hit the crop button. That's one easy way to do it. You could also just screenshot the screenshot. So I open the screenshot here, and then I got my screenshot, Command-Shift-3 again, and then just draw over that area. And now I've got a screenshot of a screenshot, which is just that window. There's a bunch of other ways that you could do this using Photoshop or other image editors. So you also have the option of taking a video if you want to do that. Once you have your screenshots, go ahead and make a new post on the Open Lab and find the Player Physics lab. And let's just call this Player Physics. And we just want a few screenshots demonstrating how our player looks in Godot with the physics added. So we added gravity and jumping physics, and then we can just drag in those screenshots. We can show our character and our new animations with the jump and show the UI as well. Those are just some options. Feel free to add in whatever you want here for your documentation. And let's take a quick look at the preview, and that looks good. So then we can publish our post and you should be done.